Try to apply whatever you are learning. You try to apply that one. Okay,
Yes, sir.
that's called smart learner. Now Newton's third law, huh? Newton's third law. You write the heading Newton's third law.
Third
Then
law.
write this statement. Write this statement. The rate of change of momentum. You know that Newton's third law in O level we got every action has an equal and opposite reaction, right?
Opposite direct reaction. Yes, sir.
Yeah. So that one now we will describe in terms of momentum. Is stated here. Can you read, Navid? This
Right.
one.
Yes.
Newton's third laws can be expressed in the terms of momentum in following way. E is the rate of change of momentum due to action force on an object is equal and opposite to the rate of change in momentum due to the reaction force on the other object.
So it's clear, right?
Yes, sir.
So you write the heading Newton's third law, and you write only the statement, the inverted comma. That one we have the statement. That one you write. Okay. Then
Like such a inverted comma only, not the other.
no, not the other, just the inverted comma one. And learn it. You learn it. Learn this
Yes, sir.
statement. It's very important. Sometimes it's very much common in case that lots of definitions are coming. Okay, so it might possible that this law, uh, the third law, might also come, and you might be asked to state this one in terms of momentum. So it's important to learn the definitions and statements. Okay, it's clear.
Yeah.
Yes, sir.
If you go through the past paper questions, then you'll find that for each of the structured questions at the beginning, in most of the cases, a definition is coming from 1 or 2 marks. Okay, so uh, you should learn the definitions and statements. This way, if you have 10 questions or 7 or 8 questions, you might have around 10 to 15 marks. Some of the definitions they have 2 marks, some of the definitions they have 1 mark. So in this way, you might have around 10 to 15 marks in definitions. Okay, that's why you should learn.
Yes,
Is
sir.
that clear?
Yes, sir.
So you understand that action. There are some more explanation here. We do not need to write them, but you just read it. That the action and reaction forces act on each body for the same time. Hence, F del T is equal and opposite for each object. Therefore, when two objects exert action and reaction forces on each other, their changes of momentum are equal and opposite. So this is a little bit discussion of the statement. With F del T, they brought the discussion. Here we have weight. Weight you already know, right? What is weight? Hmm. Levels, you have the idea what is weight. And now, what we have to just write the formula. After writing the heading weight, you write the formula W equals mg, and
Yes, sir.
this one is related to Newton's second law, right? In Newton's second law, we got F equals ma, right? So after writing W equals mg, just below it, you write F equals ma. So here we are relating weight with Newton's second law. Other things you do not need to write all these things. Just you can read. Just you can read. Ah,
Yes, sir.
yeah, this thing also you are familiar with. We do not need to, uh, you know, uh, spend our time here. We know them. You just go through these notes and also try the numerical questions. Numerical questions solution is also there. You can have a try. Now we have principle of conservation of momentum. Okay, write this heading: principle of conservation of momentum. You do not need to write everything. We will tell you what you have to write. Just you read from here, Asan. From here you read according to Newton's third law.
Third law. According to Newton's third law, if uh, if a particle exerts a force on another, then the second exerts force on the first.
Hmm.
Sir,
Hmm.
we can express it in terms of change in momentum. That is, change in momentum of the first particle will be equal, and the opposite to the momentum it changes in momentum of the second. Thus, the changes of momentum for individual particle cancel out.
Yeah. So here we whatever we got before that Newton's third law, it's very clear to us. The one force is opposite to other, right? So this one we can already we got idea in our previous discussion. Newton's third law we got in terms of momentum. Now we are getting something more here. Like we are getting the idea from here, the principle of conservation of momentum, uh, like the momentum before and after collision. We have the momentum before and after collision. That one is constant, right? Constant.
Yes, sir.
So that one is called principle of conservation of momentum. You see, it's written here. Changes of momentum for individual particles cancel out. Ah, why cancel out? Uh, Change in momentum of the first particle will be equal and opposite to the change in momentum of the second, right? That's why they are cancel out. And uh, this one we can write it numerically. We can express the situation by the equation P equals P1 plus P2 equals constant. So inverted comma statement will make us more clear it, that is written here. If no external force acts on a system, the total momentum of the system remains constant or is conserved. Again, we have some more information why uh, the system which one does not have any external force acting. This one is called isolated system. This
Yes,
one
sir.
is called isolated system. The fact that the total momentum of an isolated system is constant is the principle of conservation of momentum. So uh, here we got, if no external force acts, or we can say in a isolated system, right? Both are same thing. If someone is saying in an isolated system, the total momentum of the system remains constant or is conserved, that is conservation law of momentum. So you wrote the heading conservation law of momentum. Have
Yes,
you
sir.
written?
Law of momentum. Yeah.
Yeah. Have you written this?
So,
Principle of.
Farah will not do the class today.
I am not sure. Actually, I did not get any message from him. That's why I am. I'm giving my full intention or attention to you. Okay, they
Yes, sir.
they who joined, my all attention is there. When the class will be over, then I will try to take information from him as he did not contact. Okay,
Yes.
okay. I
Yes, sir.
think
So,
I think that is fair, right? As you joined, I should honor your time, right?
yeah,
So
obviously, sir.
yeah, so you
Sir, when
write
you will
this.
take the test?
So you write the statement. Write the statement, then we will say what we'll do later. Okay, write this statement, please.
If no external force acts. So, the inverted one, or
The inverted one you write. The
if
inverted
no
one you write.
external
Yeah, please write.
force, or if no external
And you
force
learn it,
acts,
huh? You should learn it because
yes,
we got this definition, this statement several times in years. Sometimes we understand it, but we cannot make the definition, right?
yeah,
We lose some part of the definition
words,
that, and that time we are losing marks. This type of definition normally has 2 marks. Okay, because mentioning this part, like is an isolated system, or if no external force acts on object, for this part only mentioning 1 mark, and total momentum of the system remains constant, then there is another mark. So you should focus there, right? How to learn.
yeah, yeah,
And after completing it, inverted comma part, then you write also this part. Very important. Uh, which system is called isolated system? Hmm. The system where no external force acts is called an isolated system. Just here you write till this much. The other part you do not need because already we got that idea. Till here, just the system where no external force acts is called an isolated system. And after writing this, you write uh, that one you got in Newton's second law. Ah, you got in Newton's second law. What you got? F equals mv minus mu by t. You got right? Hmm? Hello.
Yes, sir.
So that
yes.
one you write. That one you write. I'm also writing. Write this. Hmm. This way write. F equals mv minus mu bracket divided by t So this equation we already got that one we can write this way. F multiplied P equals mv minus mu. So this one we are getting mv minus mu, right? Mv minus mu
MU.
equals ft, ft, right? So change in momentum equals force multiplied by time, right? And here you see
Sir,
yes.
can we end the class?
Sorry,
Can I leave?
you want to leave the class? Are you
Yes, sir.
feeling bad?
It is okay. Yeah.
Okay, okay. Take care, huh? Take care, please. Take care, please.
Thank you. Assalamu alaikum, sir.
Walaikum salam wa rahmatullahi wa barakatuh. So look here, we have here mv minus mu, right?
Yes, sir.
So if you have mv, this one, if you think it is p1, right? Like
Yes, sir.
p means momentum, so p1 minus p2, right? We can write this way: ft equals p1 minus p2, right?
Yes, sir.
So here uh, we got in Newton's third law, every action has equal and opposite reaction, or rate of change of momentum will be opposite, right? Isn't it?
Yes, sir.
So our if our external force is zero, like if this external force it is zero or the resultant force is zero, then how can we write? We can write P1 equals P2, right?
Yes, sir.
So the momentum is equal, right? Equal and opposite, right?
Yes, sir.
Because P1 minus P2 we can write zero. So P1 equals P2 we can write. So here this statement, if no external forces acts on a system, the total momentum of the system remains constant or is conserved. This equation is matching with this statement. Okay, total momentum remains constant. It means this momentum and this momentum are equal, right? And
Yes,
conserved.
sir.
Uh, okay, so we already understood it is a direct consequence of Newton's third law of motion. Now, uh, application of this principle of conservation of momentum we will have for two objects A and B who are colliding with each other, right? And you try to
Hello.
understand it first. Hello, are you listening to me? Hello?
Hello.
Yes, Navid, are you listening to me? Hello. Problem, right, Navid?
No, sir. Sir, for some reason my computer audio cut out, so I had to rejoin.
Okay, okay. Now, uh, now we are applying principle of conservation of momentum for two objects which are colliding, right? Object A
Yes,
and
sir.
B, which has mass M1 and M2. So you see M1 and M2, these two are coming towards each other, right? Coming towards each other. So they will collide, right? And after
Yes, sir.
colliding, they are going opposite side. After the collision, they are going opposite side. So the momentum before collision we are getting for this context, for this condition, the 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 change in momentum. You see, before
Yes, sir.
before collision we have the momentum m1 u1. You see how we are giving the signs, positive and negative. It's going right side, that's why we are giving it positive m1 e1, and this one is going left side, that's why we gave negative, right?
Yes, sir.
So uh, the momentum before collision this one, and momentum after collision we got this one minus m1 v1 plus m2 v2. We can write according to conservation law of momentum. We can write this way: m1 u1 minus m2 u2 equals minus m1 v1 plus m2 v2. Okay, is it clear?
Yes, sir.
This way we can write. Then uh, we have another condition, like two objects. These two objects A and B, they are going in the same side, and after like this, B has less speed and A has more speed. That's why A will collide with B, and they will, join together, right? They will
Yes, sir.
join together. They will be now combining together, and their mass is combined also m1 plus m2, and their combined velocity is v. That time we can write m1 u1 plus m2 u2 equals m1 plus m2 into v. Is it clear?
Yes, sir.
So you please write from here uh, application of principle of conservation of momentum. You write the heading this way: application of principle of conservation of momentum. Then you write this. Everything you
Yes,
write.
sir.
We are having here before, after. Then this equation you write. So have you written this first one?
So I'm
Here,
writing. Almost done.
yeah, do it, then do the next one also.
So done.
Okay, very good. The second equation also done.
Yes, sir.
Very good. So we are done till here. Today this much. We just recap today whatever we are done. Can you tell me from your notes whatever we discussed today? From your notes.
Okay, sir. We discussed Newton's three laws,
In terms of
mass.
momentum, right?
Yes, sir.
In terms of momentum, and before that, we wrote the topic
Sir, I
name, right?
missed. I missed some part at the beginning.
Okay. Didn't you write the topic name? Topic 4 dynamics.
So what? Which one?
Topic 4 dynamics. This one you wrote. The discussion we did today from which topic? Topic 4, right? Dynamics.
Yes, sir. Force and yeah.
Yeah. Did you
Yes,
write
sir.
this?
Yes, sir.
Yeah. Then what you wrote? After writing the topic name, what you wrote?
Sir, I started from the three laws.
Okay. So you started from three laws, and before you write also before three laws you write that we have in dynamics we have also motion of the object, but
Motion of object.
yeah, motion of the object, but here we include include the force in our discussion.
Okay, sir.
So it's the difference between kinematics and dynamics, right? In dynamics we include the force. In
Yes,
kinematics
sir.
we do not discuss about the force. Okay.
Sir, what about the worksheet?
About the worksheet I uploaded.
Oh,
Uh,
okay. So in
okay.
Google Classroom, right?
Google Classroom I uploaded this note and worksheet together. I uploaded in the Google Classroom today.
Okay, sir.
Today in the morning, so you can find them there and you can have a printout over there.
Okay,
Okay.
sir.
Also, the link I gave in Messenger in the morning, you can check that. Morning,
Okay,
I
sir.
gave a link from Google Classroom where you can find the notes and the worksheet both together.
So, sir, my exam is in next class, right?
Yeah, your exam will be next class together. All of you will take the test together. Okay.
Okay, sir. Okay, sir.
Thank you. Thank you for joining. Eh? So
Okay, sir.
learned everything. And are you still continuing your previous habit? Like today, you are writing in one copy, another day another copy. Are you
Yes,
writing
sir.
that way, or the same
Yes,
copy
sir.
you are using?
So I'm writing the in one copy. I started writing it in one copy.
Okay, very good. So
Sir, I actually lost my first copy, which had first two chapters. Then I took the new copy.
but you have to collect somehow. You have to collect the notes. It's very important for your life.
Yes, sir.
Okay, otherwise you will be in trouble because without notes, you at least you if you don't can collect, then from my notes available in Google Classroom, from there you write again. It's very
Okay,
important.
sir.
You should have them. Okay, so you did not submit me topic three worksheet,
So
right?
yes, sir, I printed it and I'm doing it.
Yeah, when you'll give me after 2 months?
No, sir.
Tomorrow? Will you give
S-
me tomorrow? Hmm?
maybe day after tomorrow.
Day after tomorrow, maybe.
Inshallah.
Still maybe. Okay.
No, sir. I could submit it tomorrow, but if not, then day after tomorrow.
Okay, do it, huh? It's very
Okay,
important.
sir.
If you submit me, that means you are done with the work, and at least I can understand if there is any mistake, I can correct you, right?
Yes, sir.
Okay. Thank you so much. Give me chance, huh? To correct you.
Okay, sir.
Okay, Allah Hafiz.
Allah Hafiz, sir.